plankton form a huge and diverse ecosystem completely invisible to the human eye. And yet it was these creatures that have had by far the largest impact on life on Earth. Seriously, it was around 3 billion years ago, when the Earth was only about 1.5 billion years old, that Cyanobacteria, Earth's most abundant phytoplankton, produced the first gaseous oxygen as part of a chemical reaction we'd later call photosynthesis. Now, with this highly reactive gas present in the atmosphere, new types of chemical processes and therefore organisms could develop. Except these ones respired using this toxic byproduct of the plants to fuel the creation of their own organic matter. This is known as respiration. Between these two types of organisms, photosynthesizers and respirators, an interconnected community, or in English, the first true ecosystem, developed. Essentially, it was these cyanobacteria, these phytoplankton, that jump-started all other life on Earth. But as life became more complicated and widespread, it began to have new effects on the planet. Occasionally, these plankton would die and fall to the bottom of the ocean floor, out of the reach of organisms that could consume them and recycle their organic matter. In short, decomposers could not decompose them. Eventually, this dead organism would be buried by other sediments coming from above, and all the carbon it took from the atmosphere would become trapped beneath the ocean floor. This process is called the biological pump, as it takes carbon from the surface and sequesters or pumps it into the subsurface. And because Earth is more or less a closed system, this has had some gradual but global scale consequences. Over millions to billions of years, atmospheric carbon, mostly in the form of carbon dioxide or methane, was drained from the atmosphere and stored into sedimentary rocks. This constant drain of carbon from the Earth's atmosphere eventually depleted it, and what started out as an atmosphere of roughly 30% carbon dioxide, 10% methane, and 60% nitrogen became one with only 0.04% carbon dioxide, 0.0002% methane, 78% nitrogen, and 21% oxygen. Oh yeah, and almost 1% argon, but that's not really important. Because CO2 and methane absorb and retain more energy from the sun's rays than either oxygen or nitrogen, this change caused the Earth's atmosphere as a whole to absorb and retain less of the sun's energy.